In this video, we're going to talk about the next sensitivity analysis technique, and I'm going to show it through a graphing, the sort of a graphical method, and then I'll show you how to sort of solve the break-even questions. So an example of a break-even question is, what is the break-even life for the following investments? And this might seem a little bit odd because it's telling you that it's a 5-year life. But what the question is asking is, what if it's not 5 years? When will it still be a viable project? So one way of doing that is to calculate this base case, which is all the values they gave you, and it gives you 137 net present value. So with a 5-year life, it's a viable project. But if a 4-year life, is it viable? That's really what the question is. So what we generally do is kind of graph this, and the way you graph it is you just change the values of the life and see what the net present value is. For instance, at 5-year life, you can see it's 137, which is what we calculated. And then you find where that is that it crosses 0, where the net present value is 0, and it's approximately 4.2 years. So what that means is, interpretive-wise, is if the project lasts for longer than 4.2 years, you can see the net present value is always positive when the life is more than 4.2 years. If it's less than 4.2 years, the net present value is negative, so it's a bad project. So this is really saying, when does my decision about the project change? Now we could ask the same kind of question about this project, except for we would say, well, what is the break-even initial investment? So in this case, what we're saying is, okay, well, the thing we're uncertain about is this initial cost, this $1,000. So we'll do the calculation again at the base case, and then we'll graph this at various investment amounts. What is the net present value? And you can see as the investment increases, the net present value falls, right? Because this is a big negative initial value. And we can see here that, again, the base case at $1,000 is 137. And where it crosses 0 is 863. And in fact, we can actually calculate this 863 value by saying that setting the net present value equation equal to 0 and solving for some unknown initial investment value. See, here we had $1,000, but here we're saying it's unknown. And so what is that unknown amount such that the net present value is 0? And that's how we got 863. So again, let's look at an example. You're considering revisions to an assembly line to include more automation. The cost of the machinery is $20,000, but the annual labor savings is unclear if you automate. If the project has a 5-year life and an 8% discount, what are the break-even labor savings? So in this case, you don't even have some value. You're actually asked to find out what is the labor savings that would justify this project. So this means labor savings such that the net present value is 0. Labor savings above this amount will indicate a good project. Labor savings below this amount will indicate a poor project. So let's go ahead and solve this. We're just going to set up a net present value equation, set it equal to 0, and solve for an A value. In this case, it's 5,009. So the interpretation of this is, if labor savings need to be over $5,000 per year to make this project justified. If it's under, it's not a good project. So this gives us an idea of, well, what does that mean in the number of people, the number of hours? It kind of gives you a ballpark number that you don't have to have an exact value. You just need to know it has to be over or under this value. That's why break-even is actually a very useful tool. So in this video, we went through graphing of break-even, and then we went through an example question.